Welcome to yet another lecture. Although earlier in the course I have already briefed you about API versioning, but I thought to give you detailed overview since this is one of the important topics for software architect. When I was 5 years into my career, I was the architect responsible for a public payment API. We had hundreds of integrators companies who had built their checkout flows on top of our API, and we needed to make a breaking change. We thought we were being careful. We published a migration guide. We sent emails. We gave 3 months notice. We launched version 2. And we still broke 40 integrations on day 1. Why? Because some of those companies had developers who left 6 months ago. Some had built their systems on top of our API and never expected it to change. Some had missed our emails. Some had tested against V2, but in a way that masked the breaking change. That experience taught me that API versioning is not a technical problem. It is a communication and compatibility problem that requires a technical solution. In this lecture, we will cover every major versioning strategy, their trade-offs, the difference between breaking and non-breaking changes, how to deprecate APIs without alienating your consumers, and what consumer-driven contract testing is and why it is the most underused tool in API management. If you have a public API or plan to build one, this lecture will save you from some very painful incidents. Alright, so before we talk about API versioning and all these advanced topics, there is one very important thing. Every API developer really needs to understand clearly. What exactly is a breaking change? Because honestly, if you cannot quickly recognize a breaking change, you are eventually going to ship one by mistake, thinking it is completely safe. And yeah, this happens all the time in real projects. So let's go through some examples. First one, removing a field from the API response. Seems small, right? But imagine a mobile app is reading a field called username and suddenly that field disappears. Boom, the app crashes. Or maybe shows empty data. So yeah, removing fields is one of the most common accidental breaking changes. Second, renaming a field. For example, maybe earlier the API returned first name, and now you rename it to first_name. Technically, the data is still there, but for the client application, it's completely broken because the client is still looking for first name. So even tiny naming changes can break production systems immediately. Now third, changing the data type. This one is dangerous too. Suppose age was coming as a string like 25, and now suddenly the API sends it as an integer like 25, or the opposite. Now the front-end parser gets confused and runtime errors start happening. And honestly, these bugs are very annoying to debug. Next one, making an optional field required. So maybe earlier, clients could create a user without sending phone number. Everything worked fine. Now suddenly, your API says phone number is mandatory. What happens? Older clients that are not sending it anymore start getting validation errors. So their requests fail even though they didn't change anything. Next, changing the HTTP method. HTTP means Hypertext Transfer Protocol, basically the standard way clients communicate with APIs. So maybe earlier, clients were using POST to create something. Now suddenly you change the API and require PUT instead. Again, every existing client breaks immediately because they are still calling POST. And then, probably the most obvious one, removing an endpoint completely. If clients are calling /users/profile and suddenly that endpoint no longer exists, they just start getting 404 errors. Simple. Alright, now let's move to the safer side, non-breaking changes. These are changes that usually do not affect existing clients. For example, adding a new optional field to a response. Maybe earlier you returned name and email. Now you also add profile picture. Older clients that don't know about profile picture simply ignore it. No problem. Same thing with adding a new optional parameter. If clients don't send it, the API just uses default behavior. So existing integrations continue working normally. And adding a completely new endpoint is also safe. Because older clients don't even know it exists. Nothing changes for them. Now, honestly, when we explain these examples one by one, everything feels obvious. But in real life, under deadlines, during refactoring, with 5 or 6 engineers changing the same API at the same time, these mistakes happen constantly. Like, constantly. So, my personal advice is very simple. Add API change review into your code review checklist. Every single API change should be explicitly labeled, is this breaking, before the code gets merged. Alright, so now let's talk about the 4 main API versioning strategies. And this is important to understand. There is no single perfect strategy. Each one has pros and cons, and each one works well in different situations. So instead of memorizing them, try to understand when and why people use each approach. Alright, first one, URL path versioning. This is probably the most common versioning style you will see in public REST APIs. REST means representational state transfer. Basically the standard style of building HTTPIs. So in this approach, the version number is directly added into the URL. Something like /API/v1/users or /API/v2/users. Very straightforward. And honestly, the biggest advantage here is clarity. The moment you look at the URL, you immediately know which API version is being called. Very easy to understand, very easy to document, and also easy to test directly in a browser or tools like Postman. Caching systems also like this approach because every version has a separate unique URL. But yeah, there is a downside too. Now you basically have multiple APIs running in parallel. You have v1 and v2, maybe later v3 also. So if your API has like 50 endpoints, suddenly you are maintaining many copies over time. That maintenance cost grows quickly. Still, companies like Stripe, Twilio and GitHub use this style because it is simple, predictable and widely understood. So honestly, for public APIs, this is usually the safest choice. Now second strategy, query parameter versioning. Here, instead of putting the version in the path, you pass it as a query parameter. Something like /API/users version equals sign 2. Very easy to implement. And your URL structure stays cleaner. But there are some practical problems. Sometimes proxies or caching systems ignore query parameters. Sometimes developers forget to include them while testing. And in many logging systems, query parameters are not very visible, so debugging becomes annoying. Personally, I think this approach is okay for internal systems, but not ideal for large public APIs. Now third strategy, HTTP header versioning. HTTP means Hypertext Transfer Protocol, the communication protocol used by web APIs. In this approach, the version is sent inside request headers instead of the URL. For example, accept application/v&d, API plus v2 plus JSON. Now technically speaking, this is considered the most REST correct approach because your URLs stay completely clean and version negotiation happens properly through headers. Very elegant design. But honestly, it also creates usability problems because the version becomes invisible. You cannot see it in the browser URL bar. You cannot simply paste a URL and test quickly, and many SDK developers forget to set the required headers properly. So this approach works best when your API consumers are advanced teams with good tooling and mature engineering practices. Now fourth strategy, and this one is very interesting, GraphQL schema evolution. GraphQL is another API technology different from REST, and in GraphQL usually there is no explicit versioning at all. No v1, v2, v3. Instead, the schema evolves gradually over time. So if you need something new, you add new fields. If an old field should no longer be used, you mark it as deprecated. Deprecated basically means, hey, this still works for now, but please migrate away from it. So clients slowly move to newer fields over time. And once nobody uses the old field anymore, then finally you remove it safely. Honestly, this approach is very elegant. but it requires discipline and good monitoring. Otherwise, you can accidentally break clients without realizing it. So, yeah, these are the four major versioning strategies. And in real engineering, the best choice depends on your clients, your scale, your tooling, and honestly, your team maturity too. Alright, so this slide is about something that honestly many engineers treat like an afterthought: deprecation. And I want to say something very strongly here: most API disasters are not caused by bad code, they are caused by bad deprecation processes. Seriously. Because when you change or remove APIs, you are not just changing code. They are real companies, real teams, real businesses depending on your API. Think about your API consumers for a second. Maybe they built their mobile app on top of your API. Maybe their payment system depends on it. Maybe changing your API means they need approvals from managers, sprint planning, testing cycles, deployment windows, all of that. So they simply cannot move as fast as you want. And honestly, as API providers, we need to respect that reality. So let me walk you through the 4-phase deprecation process that I personally recommend. Very practical, very production oriented. Alright, phase 1, announce. And this should happen around 6 months before shutting down the old API version. Yes, 6 months. That sounds long, but for enterprise systems, it is actually the minimum. So what do we do here? First, publish a migration guide, very important. Don't just say please migrate, explain exactly what changed with examples. Then, add a deprecation response header to every old API response. A response header is basically extra metadata sent with every HTTP response. And automated tools can actually detect this header. Then email all registered API consumers and clearly publish the sunset date everywhere. No surprises. Now phase 2, warn. This usually starts around 3 months before shutdown. Now we become more proactive. Start logging every old API call along with the client ID. Client ID basically means identifying which customer or application is still using the old API. Now you have real data. You know exactly who has not migrated yet, and honestly, focus especially on the top consumers, the biggest users, maybe the top 20 by traffic. Reach out to them directly, offer migration help, maybe office hours, maybe walkthrough sessions, maybe engineering support. Because if these large integrations break later, the pain will be huge for everyone. Now phase 3, restrict. Usually 1 month before sunset. Now we slowly start increasing pressure, maybe start rate limiting the old API version. Then add something called a 299 warning header to every response. This is basically a standard HTTP warning saying, hey, this API is deprecated and going away soon. Also, stop allowing new API key registrations on the old version. No new consumer should start using outdated APIs. And yes, send another final email reminder. At this point, you already know exactly who is still using the old API. And then finally, phase 4, sunset. This is the actual shutdown. Now old endpoints return HTTP 410 gone, not 404. And this distinction matters. 404 means maybe this resource exists somewhere else. But 410 means permanently gone. Very explicit. But one important thing, do not immediately delete the old code completely. Archive it behind a feature flag. Feature flag basically means the code exists but stays disabled. Keep it for maybe 60 more days, just in case some emergency rollback is needed. Trust me, this safety net is valuable. And finally, publish a public announcement that the API version is officially retired. Now honestly, if you follow this process properly, clients usually trust you even through breaking changes. Because they had time, a lot of time. They had warnings, documentation, email, support opportunities. So if somebody still breaks after 6 months of communication, honestly, at that point, the responsibility is on them, not on your team. And this is how mature API platforms operate in the real world. Alright, so now let's look at how some of the best API companies in the world actually handle versioning in real life. And this part is important because every company made a different decision. And honestly, each decision teaches a different lesson. So first, Stripe. Stripe has a very interesting approach. Instead of using versions like V1, V2, V3, they use dates. So your API version might look something like August 27, 2020. Basically, every account gets locked to the API version that existed when the account was created. So if a company integrated with Stripe in 2018, they continue using the 2018 behavior forever. And yes, that old version still works today. Stripe has basically never forced customers to migrate. Think about how powerful that is from a developer trust perspective. Companies trust Stripe because integrations keep working for years, and honestly, that trust becomes a huge competitive advantage. But of course, there is a cost, a very big cost. Stripe has to maintain many API versions simultaneously in production, like over 20 versions running together, which means every new feature they build must be carefully designed so it doesn't accidentally break older versions. And honestly, this requires insane engineering discipline. You cannot do this casually. Stripe can do it because they intentionally decided API stability is one of our core product values. Now let's look at Twilio. Very similar philosophy. Twilio also uses date-based versioning in URLs. And believe it or not, some of their API versions from 2010 are still running today. That's like 14 years of backward compatibility, which is honestly kind of crazy when you think about it. But the lesson here is important. When businesses build products on top of your API, breaking that API is not just a technical issue anymore. It becomes a business relationship problem because their revenue, their customers, their systems may depend on your stability. So API stability becomes part of customer trust. Now, third example, GitHub. GitHub took a different direction completely. They moved from their REST API version 3, usually called V3, to a GraphQL API. GraphQL is a different API technology where versioning works differently. In GraphQL, usually there are no explicit versions like V1 or V2. Instead, the schema evolves gradually over time. So if a field becomes old, it gets marked as deprecated. Deprecated basically means, hey, this still works for now, but please stop depending on it long term. And meanwhile, new fields are added continuously. Clients only request the exact fields they need. So instead of version numbers, GraphQL relies heavily on schema discipline. That's the trade-off. And honestly, the big insight connecting all these companies is this. API versioning is not just an engineering decision. It's a product decision, a business decision. The companies that do this best deliberately invest in stability because they understand something very important. Client trust is more valuable than the engineering cost of maintaining old versions. And honestly, that mindset is what separates mature API platforms from average ones. Alright, so this slide is about one of the most powerful techniques in modern API engineering and honestly, also one of the most underused consumer-driven contract testing. Now, yeah, the name sounds a little complicated at first, but the idea itself is actually very simple. And once you understand it, you realize why companies at scale depend on this heavily. So first, let's understand the problem this solves. In traditional API testing, usually the API provider team writes all the tests, meaning the backend team creates tests based on their understanding of how the API should work. And that sounds reasonable, right? But here's the problem. What backend teams think consumers need and what consumers actually depend on are often very different things. And this mismatch causes production breakages all the time. For example, maybe the backend team thinks a field is not important, so they remove it. But meanwhile, some mobile app somewhere was heavily depending on that exact field. Boom, production issue. Now, consumer-driven contracts completely flip this model. Instead of providers defining expectations, consumers define what they need. And then providers automatically verify that they are still satisfying those expectations. Very powerful idea. Now let's see how this works in practice using a popular tool called Pact. Pact is kind of the standard tool for consumer-driven contract testing. Alright, step 1, the consumer writes a contract. So maybe the front-end team or the mobile app team or even a third-party SDK team, they create something called a packed file. This file basically says, when I call this API endpoint, I expect certain things. For example, when I call get/user/42, I expect ID as an integer, email as a string, and name as a string. And importantly, the consumer can also say, I don't care about other fields. So the contract only captures what the consumer truly depends on. Now step 2. This contract gets published into something called a packed broker. Broker basically means a shared service or central storage system where all contracts are stored. So now everybody can access the latest contracts. Now step 3. Inside the API provider's CI pipeline. CI means continuous integration. Basically the automated build and testing system. The provider pulls all consumer contracts from the broker and tests them against the latest backend code. Now here's the important part. If even one contract fails, meaning if the new backend code would break some consumer expectation, the build immediately fails. Before deployment, before production, before customers get impacted. And honestly, this is huge. Now final step, the can I deploy check. Before deploying a new backend version, the system asks the broker something like, can I safely deploy version 2.3, one into staging or production? The broker checks all known contracts. If everything is compatible, it says yes. If some consumer would drag, it says no. And deployment gets blocked automatically. Very clean system. So what's the final result of all this? Breaking API changes get caught early, during CI, before production incidents happen. And now the engineering conversation changes completely. Instead of, oh no, we broke a client in production, the conversation becomes, this change would break a client. Let's fix it before shipping. That shift is honestly massive. And that's why this technique is so important. It moves API management from reactive to proactive, and mature engineering organizations heavily rely on this approach to maintain API stability at scale. Alright, so now let me make all of this very practical because honestly, versioning strategy is not something where one solution fits every company. The correct choice depends on your consumers, your product speed, your engineering maturity, and honestly, how much maintenance pain your team can handle long term. So let's go through 5 real-world scenarios and what I would recommend in each case. Alright, scenario 1, a public REST API for external developers. So maybe you are building something like a payments API, messaging API, developer platform, things like that. In this case, honestly, URL path versioning is usually the safest and simplest option. REST means representational state transfer, the common HTTPI style most developers use. So URLs like /v1/users or /v2/payments. Very straightforward. Every developer immediately understands what version they are using. It is easy to document, easy to debug, easy to test, and honestly, when thousands of external developers are integrating with your API, clarity matters a lot. Now, if your company is willing to invest heavily in API stability, then you can consider something like Stripe's date-based versioning model, where customers are locked to the version they started with. That is honestly kind of the gold standard for developer experience. But yeah, it also requires very strong engineering discipline. Now scenario 2. Internal microservice APIs inside the same company. So backend teams talking to backend teams. Here, I personally prefer HTTP header versioning combined with consumer-driven contract testing. HTTP means Hypertext Transfer Protocol, and consumer-driven contracts are tools like Pact. Now, why this combination? Because internal engineering teams usually have better tooling, better CI pipelines, more mature processes. So header versioning keeps URLs clean, and then contract testing automatically catches breaking changes before deployment. Honestly, this combination works really well at scale for internal platforms. Now scenario 3, mobile app backends. This one is tricky because mobile users, they don't always update apps quickly. Some users might still be using an app version from 2 years ago. Seriously, it happens all the time. So here, URL versioning is again very useful because it is visible and easy to debug. But I would combine it with the backend for frontend pattern BFF, backend for frontend. So now the mobile team gets its own dedicated backend layer. That means they can evolve mobile APIs independently without accidentally affecting web apps or third-party clients. Very practical setup. Now scenario 4, GraphQL APIs. GraphQL is a different API technology compared to REST. And here, honestly, you usually should not use URL versioning at all. Instead, you evolve the schema gradually over time. So if a field becomes old, you mark it with something called the deprecated annotation. Annotation basically means metadata or a warning attached to the schema. And GraphQL servers can actually track which fields clients are still using. Very powerful. So once usage of an old field drops to 0, then you safely remove it. That is the proper GraphQL versioning philosophy. No V1, V2, V3, just controlled schema evolution. Now final scenario, and this one is for startups, especially very early stage startups. Pre-product market fit, meaning you are still figuring out what your product even is. Features are changing every week. APIs are changing constantly. Honestly, in that situation, adding heavy versioning infrastructure is usually over-engineering. Too early. So my recommendation there is actually simple, no versioning, but be very honest with consumers. Clearly say this API is unstable. Breaking changes may happen. We will give 2 weeks notice. And honestly, that transparency is far better than pretending to have stable versioning while constantly breaking things anyway. Sometimes simplicity and honesty are the better engineering choice. So yeah, the main lesson here is this. Good API versioning is not about following trends. It's about choosing the strategy that matches your product stage, your consumers, and your operational reality. Alright, so here is your action item for this lecture, and honestly, I really recommend you do this practically, not just listen and move on, because API versioning only truly makes sense once you apply it to your own systems. So first, start with history. Go look at the last 5 API changes your team shipped. Maybe from Git history, pull requests, release notes, wherever. And for each change, ask yourself, was this a breaking change or a non-breaking change? And if you are unsure, use the checklist we discussed earlier in this lecture. Things like removing fields, changing data types, renaming fields, all of that. Now here comes the more important question. Was that classification made before the code got merged? Or did the team only realize it was breaking after some client complained? Maybe after a production issue, maybe after somebody's integration failed. And honestly, if it's the second case, you need a better review process immediately. So this week, add a breaking change review step into your code review checklist. Very small process change, but huge long-term impact. Now next step, choose your API versioning strategy intentionally. Don't just copy what everybody else is doing. Use the selection guide from the previous slide. Match your actual situation to the correct strategy. Maybe URL versioning makes sense, maybe header versioning is better. Maybe consumer-driven contracts are more important for your architecture. A lot of teams just default to URL versions without really thinking deeply about it. Now after that, write a deprecation policy. And honestly, don't overcomplicate this. One page is enough. Just define the four phases clearly: announce, warn, restrict, and sunset. Define timelines for each phase, and most importantly, publish it somewhere visible for API consumers. Because transparency builds trust. Now, one more thing. If your APIs are used internally by other teams in your company, then please research Pact. Pact is one of the most popular tools for consumer driven contract testing. Go through their quick start guide and try to implement at least one contract test this week. Just one. Because honestly, the first time you see a breaking change get caught automatically in continuous integration, CI, before production deployment, it changes the way you think about APIs completely. After that, you will probably want contract testing everywhere. And yeah, in the next and final lecture of this section, we are going to talk about something many API courses barely cover properly: real time communication. Because sometimes normal HTTP request response is simply not enough. We'll talk about WebSockets, server sent events, long polling, and when each approach actually makes sense.
Thank you so much for watching this. Before you go, please don't forget to subscribe to my YouTube channel and turn on the notification bell so you never miss any of my upcoming videos. I regularly share valuable lessons, practical tips, and step by step tutorials to help you improve and grow. And if you are serious about mastering software design and architecture and want a complete structured learning experience, so I have created a full course that includes detailed lessons, assignments, quizzes, and downloadable workbooks to help you practice and apply what you learn. So, if that sounds helpful, just check the link in the description below and enroll in the course today. I would love to see you inside and support you on your learning journey.